Hello? Can you hear me, madam? Hello? Okay. Hello? Hello, can you hear me? Okay. Hello? Okay, now let us continue here. Today, hello? Bhanuprasad ji, can you hear me? Hello? Hello, sir, can you hear me, sir?
Good afternoon, sir.
Very good afternoon, very good afternoon. Okay, now I will continue here. Okay, sir?
Sir.
Okay, thank you. Now, just you have to see here. Yesterday, we have explained first translation theorem or first shifting theorem, second translation theorem, and the change of scale property. Okay, sir?
Yes, sir.
Now, today, you have to, yesterday also see here, some problems are also practiced on those theorems. And yesterday here, and two more problems I also referred on change of scale property. Okay?
Yes, sir.
Okay. Just to see here. Applying here, the previous problem is also see here. This is applying a change of scale property. Find the Laplace of cos 5t. Okay, sir. Now
Yes, sir.
this is the problem. Now already you have explained the change of scale properties here. Now that is the transformation of 1 by a into f of b by a being of the Laplace function.
Yes.
At the same time here we have Laplace of cos t equals to Laplace of cos t. What is the value of Laplace of cos t? Now here the expression is Laplace of cos 5t is here, and applying a change of scale property. First of all, we must know that Laplace of cos t equals to p by p square plus 1. Now that is the formation of Laplace of cos at equal to s by s square plus a square. In the same format, Laplace of cos pt equals to Laplace of cos at equals to p by p square plus a square. Here a value is 1 is here. Laplace definition, Laplace of cos t definition. Okay. Now, say given that function says that value is f of p is here. Okay, sir. Laplace of cos t equal to p by p square plus 1, and that value is depends upon the format. Laplace of cos at is here. Now, say that expression is put a equals to 1. Here the regarding of the part is p by p square plus 1. Now that value is f of p. Here p is greater than 0. Okay, sir. Now, at the same time here, just here.
Yes, sir.
Laplace of cos 5t equals to. Now, applying the change of scale property condition is Laplace of function of t equals to 1 by a into f of p by a. Now, here the value is a value is 5 is here. Okay, sir. Now, regarding that Laplace of cos phi t, now that is the format of a equals to 5. Now that value is substituting in the change of scale property. Now, what is the concept of change of scale property? 1 by a into f of p by a. Here the value of a equals to 5. That value is substituting given this expression. Now that is 1 by 5 into p value is, okay, sir. Now replacing p by a. Okay, sir. Now here that value is 1 by 5 into f of p by 5 because 1 by a into f of p by a. Now that is the value. Here the a value is 5. That value is substituting 1 by 5 into f of p by 5 regarding the part of f of p is there. Now what is the f of p? P by p square plus 1. What is the f of p by 5? P by 5 by p by 5 whole square plus 1. Okay, sir. Now, that value is p by p square plus 25. Okay, sir. Now, after the simplification, we are getting the easily substitution here. Now, here the applying of change of scale property, you are getting the value of Laplace of cos phi t equals to p by p square plus 25. Now, once a number of times I repeated here, change of scale property is f of p equals to f of p equals to 1 by a into f of p by a. That is the substitution of change of scale property. Now, just you have to see that theorem is also, once I have to see this theorem. Okay, sir? There are so many problems are also explained here. This is the change of scale property. Laplace of the function equals to f of p and the Laplace f of at equals to, replace p by at is here. Okay, sir? Here a equals to 5. That is the observation here clearly. Now that is 1 by a into f of p by a. Now, according to that, now given the problem can be solved here. Okay, sir? Next one. The above problem is also in the same manner. Laplace of sine h3t equals to. What is the Laplace of sine ht? The hyperbolic function, trigonometric of hyperbolic functions here. Sine ht of the Laplace value is 1 by p square minus a here. That is a square. Okay, sir? A by p square minus a square. Now, here the a value is 1. Now, after the substitution of the value 1 by p square minus 1. That is the expression. So, that function is say f of p. At the same time, Laplace of here sin h3t is there. Now applying change of scale property is here 1 by a into f of p by a. Now that is also in the format Laplace of f of at is there. Here the a value is 3. Now the substitution in change of scale property 1 by a means that value is 3. 1 by 3 into f of p by 3. Now in the above Laplace transformation of the function is find the value of f of p by 3 means 1 by p by 3 whole square minus 1. Now after the simplifying here, we are getting here 3 by p square minus 9. Okay, sir? That's it. In the same manner, this is also same problem here. Now some more problems is also explained here. Okay.
Yes, sir. Yes, sir.
Laplace of the function. Sir, please mute inside. Number of problems are what
Sir? Sir.
Your voice is please keep in your mute. Mute is there. Okay.
Mute, sir. Yes, sir.
Okay. Yes, more than students are also responding. Okay, sir. Given Laplace of the function equals to p square minus p plus 1 by 2p plus 1 whole square of p minus 1. Applying the change of scale property show that Laplace of the function is here Laplace of f of 2t equal to p square minus 2p plus 4 by 4 of p plus 1 whole square of p minus 2. Now the above function, just you have to observe here, Laplace of the function equals to p square minus p plus 1 by 2p plus 1 whole square of p minus 1. First of all, so that value, given the Laplace function is here, that value is say in f of p. Laplace function that is also notated as small f of p is here. Now according to that here, Laplace of f of 2t, here a value is 2. Now what is the change of scale property? Here the a value is substituting in change of scale property 1 by a into f of p by a. Here a equals to 2. That is 1 by 2 into f of p by 2. So that is 1 by 2 of replacing p by, find the f of p by 2, the above expression. P by 2 whole square minus p by 2 plus 1 by 2 of p by 2 plus 1 whole square of p by 2 minus 1. After the simplification, we are getting the solid product. Okay. That is p square minus 2p plus 4 by 4 of p plus 1 whole square of p minus 2. That's enough. Now, here given this expression, the next problem is also see here. Laplace of g of t, where g of t equals to e power, what is that? T minus a. In the power of the exponential of power, just you have to observe in the power of the expression here. That is t minus a is greater than 0, t is greater than a. Okay, sir? And that again, that g of t equals to 0, when the condition is applied here, t is less than a. Okay. Now here the, just you have to see here, Laplace of the function equals to f of p. Okay. Now that value is g of t equal to, here the given the part is g of t equal to f of t minus a, capital F of t minus a, t greater than a. Here g of t equal to 0, t less than a. Now what is the value of Laplace of the g of t value? Okay. Now this expression depends upon the exponential order of the part is Laplace of g of t equals to e power minus ap into small f of p. Now here f of t equal to, what is the value of f of t? E power t is there. Put ap equals to t here. Laplace of the function means Laplace of e power t. Already we have that expression depends upon the e power at is there. Okay, according to that, Laplace of the value is e power t 1 by p minus 1. Okay, sir. Because a equals to 1, that is 1 by p minus a. Okay, here the a value is 1 here, because exponential of the value in the power of the value a equals to 1 is there. So that is 1 by p minus 1. So here p must and should, that value is greater than 1 is there. So that function value is saying f of p here. Okay. Now at the same time, just you have to see here, g of t equals to, that is the given part. F of t minus a equals to e power t minus a, because according to here, say here f of t equal to e power t, and in g of t equals to f of t minus a notated as e power t minus a. That is t is greater than a. Now Laplace of g of t equals to e power minus ap into f of p. Now that is the conditional part. E power minus ap by f of p values, we are just the above result is here. That value is 1 by p minus 1. Now that is the proved part. Here p is greater than 1. Alternate method is also here. There is no problem. Okay, that's enough. Next, in the same manner, just you have to see referred and more than problems here. Now, directly Laplace transform of derivatives. This is one of the most important content. Okay, sir. This is one of the most important part in Laplace transformation. Now, how to find the Laplace transformation of the derivatives? Okay. Now here the derivative of the expression is, here the function is f of p is there. Now there are more than derivatives here. F dash of p means df by dp, and f double dash of p means d square p by dt square. And in the same manner, Laplace transform of derivatives means, now here the function is capital F of t. Now that function must calculate through the Laplace transformation of the derivative. Now here the every function, given the function must be a continuous part. Okay, this result is much more important, and further applications of more than problems you have to practice here. Okay, now let f of t be continuous for all t is greater than or equal to 0, and be of exponential order a as t tends to infinite. If f dash of t is class of a, now here a be any one of the class, that class of the function is, say, f of t is there. Now more than functions also must be derived through the derivatives, sir. Okay, sir. So in the class of the function is f dash of t, how to calculate, because through the continuous part. Then Laplace transform of the derivative is f dash of t must exist. Already we know some other theorems in real analysis part. Continuous function. Okay, every derivable function is continuous, but continuous function is not derivable here. Okay, and according to that, what is the derivative of the function? There is a simple expression. The first principle of the derivative is f dash of x equals to limit x tends to a, f of x minus f of a by x minus a, and the limit t tends to a means f of t minus f of a by t minus a. Here t is greater than a is the part. Okay, sir. Now, according to that, here the function is f of t, then the derivative of the function is f dash of t. That derivative of the function must be exist here, p is greater than a. Okay. So here Laplace of f dash of t equals to, we have to prove here, we must prove it through the Laplace function of the derivative is p into Laplace of f of t of minus f of 0. This is the expression of derivative of the function on through the Laplace part. Okay, just we have to see the proof of how to get in the value, how to get in the derivative through the Laplace transformation of the function. Now in the first case is here, there are number of derivatives how to calculate. Just listen carefully and C is also here. In case f dash of t is continuous, derivable function is continuous. Already you have to state it here. Okay, that is f dash of t is continuous for all t is greater than or equal to 0. Then Laplace of f dash of t equals to, what is that? Laplace of f dash of t equals to integral 0 to infinite e power minus pt into f dash of t dt. Okay, now this is the Laplace function. What is that? What is the Laplace function? L of f of t equal to integral 0 to infinite e power minus pt into f of t dt. Now replacing f of t by f dash of t. Here the value is taken from the function of f of t and the replacing of f of t by f dash of t. Now integration by parts here. E power minus pt is also standard here. F dash of t integral. That is the your integral u integral v format is there. Okay, sir. That is integral u integral v format is now that is uv means u means e power minus pt. Integral of f dash of t means f of t. Now that integral varies from 0 to infinite. Minus of minus because e power minus pt integral part is what is that? E power that is the derivative part is minus p into e power minus pt. So minus of minus is plus p integral 0 to infinite e power minus pt into, again the function is f of t dt is there. Now that is defined from integration by parts in the above expression is here. Now that first part is also expressed in the format is the Leibniz concept here. Limit t tends to infinity to e power minus pt into f of t minus, because here minus f of 0 is there. Replacing of the value here, that infinity upper limit is also substituting in the first part is here. Upper limit is infinity and lower limit is 0. And according to that, here limit t tends to infinite e power minus pt of f of t. Okay, that is the upper limit minus the lower limit part is replacing t by 0. That is f of 0 is there because e power 0 is 1 is here and 1 into f of t is f of 0 is f of 0. Now that part is second part is same in the manner p into, now that part, that value is an equivalent to Laplace of the function. Okay, that value is an equivalent to Laplace of the function. Okay, sir. Now this function mod f of t is less than or equal to, already see here, that is the existence of Laplace transformation. Absolute of the function is less than or equal to capital M into e power a t is here for all t is greater than or equal to 0, and for some constants here a and m we have. So that value is here absolute of e power minus pt into f of t. This is the part. Okay. Now that value is e power minus pt into absolute of f of t, can also be written as here. Enter that value less than or equal to e power minus pt into, now that function of the absoluteness means capital M into e power at. Okay, that is the substitution of the part. Now capital M is here, constant is there. Now e power minus pt into e power at can also be written as a power m into a power n expression, that is a power m plus n, that is e power minus of p minus e of t. Now enter that value must tends to 0. Here as t tends to infinity when p is greater than a. Now hence the final expression is limited t tends to infinity. Okay. But this is linear transformation. One of the students is also mentioned here. One of the just see this message, see your message. And this is the linear transformation from the beginning of the part. Okay. This is the third part of third day of Laplace transformation. Now, here e power minus pt into. Okay, thank you. So, this is the third part, Laplace transformation of the derivatives. Now here, now mod absolute of f of t is less than or equal to capital M into e power a t. That value substituting here, we are getting the expression is e power minus pt into f of t of the limit is 0. So finally, we are getting the value in the first part. See in the first equation, second equation, just you have to observe here. Limit t tends to infinite e power minus pt f of t, okay, minus f of 0. Okay, so first part value is 0 because t approaches to infinity, enter the part is 0. When the given the final expression is Laplace of f dash of t equal to p into Laplace of the function minus f of 0. Okay, from the second equation. That is the final conclusion of derivative of the Laplace function. What is the value? Once you have to repeat on Laplace of f dash of t equal to p into Lf of t minus f of 0. Just see in your textbook is also there. Now here p is the parameter, and in your textbook enter the part is in terms of s is there. There is no doubt. Here s into L f of t minus f of 0. See in your textbook, that is the Laplace transformation. Just you have to enter my class. Just you have to observing BF upon the screen part is there, and the screen sharing is also at the same time. Now just you have to at the end of the class you must refer, see in your textbook is there. Okay, there is no problem. Laplace of the derivative is p into Laplace of the function minus f of 0. That is the first derivative of the Laplace function. In the same manner, we are getting the much more results, second derivative of the function and the third derivative of the function and number of. Now, according to this one, the first part, second case is there. Okay, when it is piecewise continuous, the integral first may be broken as the sum of integrals in different changes from 0 to infinite. That is, f dash of t is continuous in each of such parts. Okay. Now, in the case one, finally, Laplace of f dash of t equal to p into Laplace of the function minus f of 0. Now, these are in the jump discontinuities there. There are discontinuous functions. Do you know discontinuous functions? When the function which is not continuous, now that function is called a discontinuous function. And there are so many discontinuous functions are there: removable discontinuity, jump discontinuity, first kind of discontinuity, isolated discontinuity, and that is also comparing it with the singularities is also there, are also there in complex analysis. Okay, removable singularity, essential singularity. Okay, now there are both are simultaneous ultimate part in especially in discontinuous functions and singularities also there. Okay, now here. At the same time, then proceeding as in case one, we shall have Laplace of the f dash of t equals to p into Laplace of the function minus f of 0. Now, when the function must be continuous at t equal to 0, given the function must be continuous at t equal to 0, but limit t tends to 0. The above expression t tends to infinity is there. But here limit t tends to 0 of the function is f of 0 plus 0. That can also be written as f of a plus 0. Or a means here 0 is there, point is 0. Now it is defined from t equal to 0, means t tends to a. Now that value is substituting here, that is the right hand continuity expression. Limit extends to a, limit extends to c, f of x equal to f of c, then absolute of f of x minus f of c is less than epsilon. At the same time, here the continuity is also explained. When the limit t tends to 0, f of t equal to f of 0 plus 0 means that is the right continuity. That is also existence part. Okay. Now, here, next page is there. See here. Please stay on the line. Please stay in the lens. Okay. Now, these are all problems of continuity functions and every and when the function which is not continuous, that is called a discontinuous function. Okay, sir. Now see here. Now that is f of 0 plus 0 is not equal to f of 0, either which may or may not exist. So finally, Laplace of the function defined at t equal to 0 means Laplace of f dash of t equal to either P or S, whatever the representation. Now, that representation is, I have to take in that representation in terms of P is there, P into L Laplace of the function minus f of 0 plus 0. Okay, when it fails continuous at t equal to a, so that is note 2 is there, then Laplace of the derivative function is P into Laplace of the function minus f of 0 minus e power minus ap into, now in terms of a is there, f of a plus 0 defined at t equal to a is there. Okay, e power minus ap into capital F of a plus 0 minus f of a minus 0. So that value is in bracket. Just you have to see in the brackets part. F of a plus 0 minus f of a minus 0. Given the function is defined at t equal to a, now then the upper limit minus lower limit, upper continuous and right continuous minus lower continuous, t tends to a. Now that is the meaning of that part is called jump discontinuity is there. F of a plus 0 minus f of a minus 0 is called jump discontinuity. Okay. Now, according to this here, Laplace t tends to infinity e power minus pt f of t equals to 0. How to explain the jump discontinuity part? See this proof here. Laplace of the first derivative of the function means then the definition, according to that, the definition is integral 0 to infinity e power minus pt into f dash of t dt. And that can also be written as stated as 0 to infinity means 0 to a and a to infinity in the definition. Okay. So in the Laplace definition, f of t is replacing f of t by f dash of t. Okay. Now at the same time, here that expression is also integration by parts. First part can also be written integration by parts, and the second part is integral 0 to infinity e power minus pt into f dash of t. Means this is e power minus pt f of t, first part is e power minus pt f of t 0 to a plus p into minus of minus p is plus p integral 0 to a e power minus pt f dash of t dt, f of t dt. Plus, and again second part is also can be divided into two parts because that is also integration by parts. Now then after the simplification, e power minus ap, already this value is also found the above part is there. E power minus ap into capital F of a minus 0 minus f of 0 plus limit t tends to infinity. Again this one e power minus pt into capital F of t. So minus e power. So in the last part is also substitution of the parties here. Now finally we are getting the value is p into Laplace of the e power minus pt into Laplace of the function is 0 is there. Limit t tends to infinity e power minus pt into f of t equal to 0. So this is called this part is the jump discontinuity part. Now after the simplification, we are easily find out the part is easily found the part is p into Laplace of the function minus f of 0 minus e power minus ap into f of a plus 0 minus f of a minus 0. This is called, this expression is called jump discontinuity at x equal to a from the first derivative of the Laplace function. Okay, that's enough. Okay, explain any one of the discontinuity on the first derivative of Laplace transformation means now this is the proof. Okay, now there are number of derivatives is also found here. Now that is the Laplace transform of nth derivative part. Now that is the easily expression is here. Laplace, then let f of t and its derivative f dash of t, f double dash of t, so on n minus 1th derivative of the function must be a continuous function for all t is greater than or equal to 0 and be of exponential or dash as t tends to infinity and nth derivative of the function is of class A. Now what is the expression? Laplace of f power n of t, and now it read as nth derivative of the Laplace function, means nth derivative of the Laplace transformation is p power n into Laplace of the function minus p power n minus 1 into f of 0 minus p power n minus 2 into f dash of 0. Now just have that is the formation of just like that Taylor concept, and at the same time Leibniz rule is also applied here. Okay, there is no problem. Now there are so on n minus 1 the derivative of the function at 0. Okay, now already in Taylor concept is there. F of b equal to f of a plus b minus a by 1 factorial into f dash of a plus b minus a whole square by 2 factorial into f double dash of a plus so on n minus 1 rth remainder is there, Rn. Okay. Now according to this one, from the first derivative is Laplace of the function L f dash of t equal to p into Laplace of the function minus f of 0. How to find the second derivative of the function? That is Laplace of f double dash of t can also be written as p into Laplace of f dash of t minus f dash of 0. Now that is p into means p of how to write this one? Laplace of f dash value is substituting in here. P of p into L f of t minus f of 0 minus f dash of 0. P of p is, sir, do you understand here? P into Laplace of f dash of t minus f dash of 0 from the first derivative of the function. Now first derivative is p into L f of t minus f of 0. Now here the substitution the f of t by f dash of t you should be taken. Now that value is also substituting of the Laplace of first derivative in terms of L f dash of t. Okay, that is p of p means p square L f of t minus p f of 0. Again L f of t means p f of 0 minus f dash of 0. So that is the second derivative of the function is p square into Laplace of the function minus p f of 0 minus f dash of 0. This is the second derivative of the Laplace function. In the same manner, just you have to see here. Laplace of third derivative of the function is p into Laplace of f dash of t minus f double dash of t minus f double dash of 0. So from the first derivative of the function f of t by f double dash of t. Now that is p of, again that value is also substituting. Hello?
Yes, sir.
Okay, sir. Now p of, listen carefully, sir. This is one of the most important concept, entire Laplace transformation. Those persons are also just have to move 1 minute to 1 minute here. Okay.
Yes, sir.
Please stay on the line, sir. Okay. So this is, listen carefully. This is p of p square means p cube Laplace of the function minus p square f of 0 minus p into f dash of 0 minus f double dash of 0. This is the third derivative of the function means Laplace of f triple dash of t equals to p square into p of p square means p cube Laplace of the function. This is the third derivative part. In terms of p cube is there, p cube Laplace of the function minus p square, p power n minus 1, 3 minus 1 is 2, p square f of 0 minus, again n minus 2, means 3 minus 2, 1. That is p into f dash of 0 minus f dash of 0 is here. Okay. Now, again, this value, this is the third derivative of the expression, and you have to express the nth derivative of the part. Now, in n terms of the derivative, nth derivative means nth order here, Laplace of the f power n of t. Nth order of the derivative means p power n into the above expressions is also comparing it with the nth derivative is there. Okay. Now that is p power n into Laplace of the function minus p power n minus 1 of f of 0 minus p power n minus 2 f dash of 0 minus 1 minus f power n minus 1 of 0. Now enter the term. First term is the same manner. Enter remaining terms are also minus is common. That is minus of overall the party summation of the party summation r equal to 0 to n minus 1 p power n minus 1 and minus r into f power r of 0. Okay. Now simply expressed as in terms of r is here Laplace of f power n of t equal to p power n into Laplace of the function minus summation r equal to 0 to sigma r equal to 0 to n minus 1 p power n minus 1 minus r into f power r of 0. That's enough. Now, see this here, initial value theorem. Now, initial value theorem, final value theorem. Then you have to see some other problems are also depends upon these theorems. Okay, sir? Let f of t be continuous. That is the simple expression. Please just listen carefully, sir. Okay. Now, initial value theorem means what is the initial condition and how to express the initial condition in terms of t values with respect to the Laplace transformation is that is let f of t be continuous for all t greater than or equal to 0 and be of exponential order. Okay, exponential order as t tends to infinite. And if derivative of first derivative of the function is of class A, function of class A, what is the function of class A? That is also already explained in the first class of Laplace transformation. Okay. Then limit t tends to infinity to f of t equals to, again, that value expressed in terms of t is here. What is the value of limit capital F of t? Limit function when t approaches to infinite means limit p tends to infinite p into Laplace of the function. So that is the initial value concept. Okay. Now, already you know that derivative of the function can also be written as in terms of the that expression, particularly as on limits is here, limit t tends to infinity to f of t. Means that is the f of t is here. Okay, that is small f of t is here. So that function is must be defined. Continuous function is defined on every derivable function is continuous. And according to that continuous function, we have to express the derivative is f dash of t can also be written as limit t tends to infinity to f of t equal to limit p tends to infinity to, in terms of p expressed here, p into Laplace of the function. By theorem, Laplace of the definition is also first note down. That is the proof. Laplace of f dash of t equals to integral 0 to infinite e power minus pt into f dash of t dt. So that value is an equivalent to p into Laplace of the function. So this is sectionally continuous part. The derivable part is sectionally continuous. Already we know how derived the result is in exponential order is limit p tends to infinity to integral 0 to infinite e power minus pt into f dash of t dt equal to 0. Sectionally continuous part. Now already how proved this part. Okay.
Yes, sir.
Okay, sir. Now limit p tends to infinite integral 0 to infinite e power minus pt into f dash of t dt equals to 0. Taking limit as p tends to infinity in the first equation we have, so that value, this value is substituting in the first equation is there. So this is the first equation, sir. Okay, that in the integral part is also taking that value is 0 equal to p into Lf of t minus f of 0. Now we are taking the limits, limit p tends to infinity. So finally we are getting the result is f of 0 equal to, from this session. Okay, sir, this expression f of 0 is also taking at right side, left side, f of 0 equal to limit p tends to infinity p into Laplace of the function. So finally we are getting the result. P approaches to infinity means here limited in terms of t is there, limit t tends to 0. F of t equals to limit p tends to infinity. F of 0 is equivalent to limit f of t. F of 0 can also be written as limit t tends to 0 f of t equals to limit p tends to infinity to p into Laplace of the function. Okay, that's enough, sir. This is the initial value concept. And what is the final value theorem? Initial value theorem is also proved here. Okay, suppose according to this one, much more useful in further further solutions, further problems also. It depends upon the Laplace transformations. Okay. Next one. This is the final value theorem. Let f of t be continuous for all t is greater than or equal to 0. Enter these continuous functions. These functions must be continuous. That continuous of the variable must be greater than or equal to 0 and be of exponential order. First ladder, ultimately exponential order means the above result just you have to see here. Okay. Limit p tends to infinity to integral 0 to infinite e power minus pt into f of t dt equal to 0. Okay. Now that formula that formula should be remembered here. Okay, sir. Next one. Limit t tends to infinite f of t equals to, now those functions depends upon the class part. This is here the class represented as capital A. Now according to that class, now you have to consider that there are so many functions are there, that those functions must be defined. Defined the part, derivable part is there, and that derivable depends upon the through the Laplace transformation how to calculate from the initial value section and the final value part. Okay. Now this is limit t tends to infinity f of t equal to limit p tends to 0 p into Laplace of the function. Okay. So this is the one of the expression. This is the final value theorem, and at the same time, see here. Okay, sir. Now just you must be patient here. Taking limit as p tends to 0, the above expression. Okay. Now that can also be written as limit p tends to 0. Already derived here.
Sir.
Okay. Tell me.
Sir, excuse me, sir.
Okay.
Sir, which chapter you are taking, sir?
Already explained, madam. This is the Laplace transformation First of all, Laplace transformation. We have explained the definition of Laplace transformation of the function. Okay. See in your textbook is there. Are you new join?
Okay.
Madam? Are
Yes,
you
sir.
new join
Today
here?
only I am first class, sir. This is
Okay.
my first.
Don't
This
worry.
is my first class, sir. Yes, sir.
Okay, no problem. Already you have just have
Sir,
to interact.
this is 8th B, sir.
8B. This is the methods of applied mathematics. Okay, methods of applied mathematics paper. Now already 3 concepts are also completed. This is the 4th concept, Laplace transformation, and that Laplace transformation already have completed the definition and some formulas derived. And the first shifting, second shifting, change of scale property, and this is initial value concept is there. This is the final value concept, final value theorem. Okay, madam. Okay. Now, this is limit p tends to 0, integral 0 to infinite e power minus pt into f dash of t dt equals to limit p tends to 0, p into Laplace of f of t minus f of 0. Okay. So, integral 0 to infinite f dash of t dt equals to limit p tends to 0 means first part. First derivative of the function, limit p tends to 0, p into Lf of t minus f of 0. Finally, we have to derive it. So final value theorem can also be proved here. Limit t tends to infinity f of t equals to limit p tends to 0, p into Laplace of the function. So what is the difference between initial value theorem and final value theorem? Just you have to see this here, the final part. That value is also expressed in terms of t approaches to infinity, and here p tends to 0 from the continuity part is here. Okay. Limit t tends to infinity f of t equals to limit p tends to 0, p into Laplace of the function. This is the, if the function, if we at any time, if the function fails to be continuous at t equal to 0, but limit t tends to 0, f of t is also explained here. Okay. That's correct. Now, here the concept is, once again, here the concept is, see this one, Laplace transform of integrals. Already calculus, transformation functions means first every function must be calculated. Now those functions depend upon the limits, continuity, and integrability. Okay. Now, just here the concept is Laplace transformation. That is also one of the such function is here. Now the transformation of the function must be defined. The limit part is there, and the next one continuity explained. And according to the continuity, how to explain the derivative part is also. Okay. Now just final part is Laplace transform of integrals. This is the calculus of Laplace transformation of function. Okay. Calculus means that is the combination of differentiation and integration here. Now, especially the derivable part of derivative is also defined on Laplace function, and at the same time, integral of how to calculate and how to define the integral part nature depends upon the Laplace transformation of the function. Just you have to see here, if f of t is piecewise continuous, given the function is piecewise continuous means, suppose already yesterday, the previous classes are also explained here. What is the sectionally continuous or piecewise continuous? Just you must watch, and you must watch the YouTube classes. Now all the doubts are clarified here. Okay, no problem. Because the previous classes you must watch there. Okay, Laplace transform of integrals. Here, if f of t is piecewise continuous and satisfies, absolute of f of t is less than or equal to capital M into e power at. So that is the existence of the part, means a piecewise continuous part is here. Okay. Now for some constants a and m, according to this one, already this concept is also derived in the previous classes. Mod f of t means absolute of the function less than or equal to capital M into e power at. For some constants a and m, here Laplace of the part integral 0 to 1 f of x dx equal to, just you have to see and listen carefully. Laplace of the integration notated as Laplace of integral 0 to 1 f of x dx equal to 1 by p into Laplace of the function. Okay, sir. Laplace of integrable function. That integral of the limits 0 varies it varies from 0 to t. Okay. Now origin from defined from origin is here. Laplace of integral 0 to t f of x dx equals to 1 by p into Laplace of the function. Okay, sir. Now, this is the expression. Now, then the proof of Laplace integration is how to define the Laplace integration, Laplace transform of the integrals. Let f of t be piecewise continuous part means piecewise continuous part means mod f of t is less than or equal to capital M into e power a t is there for some constants a and m. Now that equation, say that is the first equation. That first equation holds for some negative values of the part. It holds for positive values of a. So newly function, you have to express the newly function because here a is positive is here g of t equal to, that is capital G of t equals to integral 0 to t f of x dx. Okay. Here that function, new function is g of t is continuous. That is then their absoluteness of less than or equal to integral 0 to t absolute of f of x dx. So both sides are also applying at the same time absoluteness for a continuous part. It is less than or equal to absolute of the function values capital M into e power ax. Okay. Now, finally, we are getting the mod g of t is less than or equal to, because Laplace integration is denoted by g of t, our convenience. Here, mod g of t is less than or equal to capital M by integral e power ax means, what is that? Integral e power ax means e power ax by a. Okay. Substituting of the limits is 0 to t, that is e power at by a minus lower limit is 0. We are getting the values 1 is here. Finally, so a value is taken outside of the part, that is m by a of e power at minus 1. So Laplace integration must be that function, integrable function must be bounded here. That boundary value is m by a of e power at minus 1, e power at of minus 1. Here a is greater than 0. So this concept is also depends upon the g dash of t. G dash of t represented as capital F of t, except for points at which f of t is discontinuous. When the function must be discontinuous part, except the points at which f of t, means g dash of t represented as capital F of t. That is the piecewise continuous on each finite intervals and is of exponential order. So finally, we are getting the expression is Laplace of g dash of t, means primitive of the function. G of t is the integrable function. G dash of t means that is the primitive function. So that is anti-primitive is there. Anti-primitive means g dash of t represented as anti-primitive. Laplace of g dash of t equals to, in terms of g is there, that function should be taken here in terms of integrable function p into Laplace of g of t minus g of 0. Okay, sir. So see this here. Okay, there are so many functions are also expressed here. This is, say this one. Okay, this is the Laplace integrals, and final expression is p into Laplace of g of t. So that is Laplace of g of t. P is also taking out that side 1 by p into Laplace of g dash of t. So g of t is also substituting the value, substituting of the part. So that is the integrable function on Laplace transformation. That is Laplace of integral 0 to t f of x dx equal to 1 by p into Laplace of g dash of t represented as f of t. So that's enough. That is the concept of Laplace transformation of integrals. Okay, sir. Now here the one of the important contained in a Laplace transformation is multiplication by powers of t. Okay. Now these theorems must be utilized in the further problems are also can be solved. Okay. Multiplication by t. So with respect to t, when the t is multiplied with the Laplace transformation of the function, that is noted by minus f dash of p. Okay. So simply multiplication by t means multiplication by powers of t. Okay. Now here the f of t is a function of class A if Laplace of the function is represented as f of p. So that is Laplace of function means t of replacing f of t by t f of t equals to minus f dash of p. So that is the expression of multiplication by t of the Laplace transformation. So this is the important content or concept in Laplace transformation. Once I repeated here, if f of t is a function of class A, and if Laplace of the function is say, that function say f of p. So that is Laplace of t, f of t equal to minus f dash of p is here. Okay. Now, here the proof is there. We have f of p equals to, what is the meaning of f of p? Laplace function. That is L f of t equals to integral 0 to infinite e power minus pt into f of t dt. That's enough. Now, here the expression is f dash of p equal to, okay, this is the Laplace function. F dash of p means d with respect to the function. Hello? This is the Laplace function definition, sir. What is the meaning of f dash of p? D by dp. Okay, sir. D by dp of Laplace function. Okay. That is the meaning of the f dash of p. Now, integral part is also taken outside. Integral 0 to infinite dou by dou p of e power minus pt into f of t dt. This is the just here by Leibniz rule for differentiating under the sign of integral. Leibniz rule for differentiating under the sign of the part. Already yesterday, some formulas are also sent to PDF part. Now every class now using the format and the formulas, consent formulas posted through PDF in your group is there. Okay, sir? Just you have to see it. What is the Leibniz concept? Dou by dou p of e power minus pt of f of t. So e power minus pt derivative is minus t into e power minus pt f of t constant. Okay, sir? Here the function is constant. That is f of t is the same part. E power minus pt of the derivative is in terms of p is there. Exponential part is in terms of p is here. So what is the derivative of e power nx? N into e power nx. Here the n value is minus p. So that value is substituting here minus integral 0 to infinite t into e power minus pt into f of t dt. So final expression is minus integral 0 to infinite e power minus pt of t f of t. So just given the problem, you have to observe this one in examination. Suppose any function must involving with t or t square or t cube, whatever it is. Okay. Now, at the same time, you must generate the formula is multiplication by t is there. Okay. So again, that value is minus Laplace of with respect to t function. So that is minus L of t f of t is there. So finally, Laplace of multiplication with respect to t multiplied by t of the function is minus f dash of p. So that is the multiplication by t. That is the theorem. Okay, sir. Laplace of the function is multiplying with the t is denoted by minus f dash of p. That's enough. Okay. Now multiplication by t power n. Suppose t power is by power is 1 is there. Put t equal to 1. But here at the same time t square, t cube, n value, n represented as the 1 is there. Now we are getting the easily simplified. Okay, sir. Laplace of t power n equal to 1 here. The above theorem is also applied. Hello?
Yes, sir.
Okay. At the same time, put n equal to 2 is there. N equal to 2, 3, and so on up to n values. Now, how to get the values? That is Laplace of t power n, f of t equal to minus 1 whole power n into d power n by dp power n of f of p. So that is also in the, now that derivation is also defined from the above multiplication by t. Okay. So put n equal to 1 here, n equal to 2. Now the easily simplified minus 1 whole square into d by dp of f dash of d by dp, d square by d by dp of f of p. Okay. So that's enough. Suppose, hello?
Yes, sir.
Okay. Laplace of t square f of t means minus 1 whole square into this expression. Put n equal to 2 is there. Minus 1 whole square into d square by dp square of f of p. N equal to cube. Laplace of t cube f of t. Okay. With respect to t cube function, any function along with given the Laplace function is there. So t power n means here n equal to 1, 2, 3, and there are so many values are also there. There are so many integers. Now those values is along with given the Laplace function. Now this formula easily derived here. Minus 1 whole power n into d power n by d power n of f of p. Okay, that's enough. See, you have to refer this one. Now easy to understand here. Okay. Next one, division by t. Division by t. Division means before that function, Laplace function is multiplying with t. Division means t inverse. T inverse means 1 by t. Okay. That is Laplace function equals to f of p. Then Laplace of 1 by t into f of t equals to integral p to infinite f of x dx. So already integrable function is, you have recently derived here, division of the part. Now that according to that division by t is their Laplace of 1 by t into f of t equals to integral p to infinite f of x dx. So that is, it is provided that when t approaches to 0, that integrable of the function of the limit must be exist. Okay, sir? The function must be exist. Okay. Now, how to derive? So that inverse function means that the inverse function means 1 by t into f of t. Say that part is denoted by capital G of t. Okay. When the cross multiplication is here, f of t equal to t into G of t. Okay. This is the division by t. Explain the multiplication by t and the division by t on Laplace transformation. Means both terms are also involved here. Okay, sir? That is f of t equals to t into G of t here. Okay. That's enough. That is Laplace of f of t equals to Laplace of t into Laplace function. Laplace transformation is also applied the above consideration. Okay. So that is minus d by dp of Laplace of G of t. By previous theorem is there. So that is f of p, because t equal to 1. T equal to 1 means minus 1 whole power 1. Minus 1 whole power 1 means minus. D power n by dp power 1. Okay. So Laplace of the function is there. So finally Laplace function is an equivalent to f of p. So that value is minus d by dp into Laplace of G of t. Substituting that expression is here. So finally minus L of G of t. So values is also substituting from where p to infinite. That value is an equivalent to integral p to infinite f of p dp. Both sides integration is also applied. Okay. When the integration is applied in the above expression, f of p equal to minus d by dp L of G of t. Integrating with respect to p from p to infinite. Okay. So the d by dp integration. Okay, that must be deleted here. In the at the same time, limits is also applied here. Now the right hand side of the part integral 0 to infinity to f of p dp. Okay. Then after the simplification, we are getting the result is here. Limit integral p to infinite f of p dp equals to minus limit p to infinite Laplace of the function g of t plus Laplace of g of p is there. Okay. So final value is Laplace of first expression is 0. Laplace of g of t equals to integral p to infinite f of p dp. So in the bracket expression is there. Now that value is also is previously already proved here. Okay. Limit p tends to infinity to integral 0 to infinite e power minus pt into g of t dt equals to 0. So finally we are getting the result g of t value. So express g of t is substituting here Laplace of 1 by t into what is the g of t? 1 by t f of t equals to what is the final expression? Integral p to infinite from p to infinite f of x under dx. Okay, that's enough, sir. These are all theorems. Initial value theorem, final value theorem, multiplication by t and division by t. Okay, sir. And multiplication by t power n. These theorems and from already first shifting theorem, second shifting theorem, change of scale property, according to all those theorems, and but it is completely depends upon their further upcoming problems are there. Okay, just you have to refer the problems. Laplace of t equal to 1 by p square. Be careful, sir. Okay. Laplace of t equals to 1 by t square. Given the function is f of t equals to t. First of all, what is the derivative? Now these three functions derive each of the following Laplace transformation from the along with the derivative. Okay. Now we have Laplace of f dash of t equals to p into Laplace of f of t minus f of 0. According to the problems are also easily understood here. Okay, sir? No problem. Here let f of t equals to what is the function of t? in the first problem. That is t. Okay, see here, sir.
P.
Okay,
Yes, sir.
Laplace of t equals to 1 by p square. Here,
Yes, sir.
function of t means t is there. What is the f dash of t? That value is 1. F of 0 equal to f of t equals to t, f of 0 equals to 0. Okay?
Yes, sir.
From first equation, now this is the first equation of the part, first derivative of the Laplace function is p into Lf of t minus f of 0. Number of times that for that derivative, entire all formulas must be repeated here. Okay, sir? So many times are repeated here. Now that must at the same time, for your convenience, that formulas must be generated at the same time. Okay.
Yes, sir.
So that is Laplace of t equals to 1 by p into. So see here, from first equation we have Laplace of 1 equal to Laplace of f of t means the Laplace of 1 equal to p into f dash of t value is 1. Those values substituting here. Laplace of f dash of t equals to 1, p into Laplace of f of t equals to t minus f of 0 equals to 0. These values substituting in first expression. So we are getting the result is Laplace of t equals to 1 by p into, okay? Laplace of t value is 1 by p, okay?
Yes, sir.
So finally, Laplace of t, f dash of t means Laplace of f of t equals to f of 0 plus 1 by p into Lf dash of t. Okay?
Yes.
Lf dash of t equals to p into Lf of t minus f of 0, sir. Now here the value substituting in the first equation. Given the function is there. Given the function is small t is there. Just you have to observe L of t equals to 1 by p square is there. Now that value must be proved here. Okay. Now, what is the value of f of t? That value is small t. Okay. According to that function, f dash of t equals to 1. And in f of t, replacing t by 0, f of 0 equals to 0. These values substituting in the first derivative. Okay. Now, Lf of p into Lf of t equals to, from first equation, can also be written as p into L. Just please. Okay, sir. So p into Lf of t equals to f of 0 plus f of 0 plus L f dash of t. That's enough. Here, L of t equals to, just see here, sir. Laplace of the function f of t is also substituting t. L of t equals to 1 by p into L of 1. We are finally 1 by p into 1 by p. Laplace of 1 equals to 1 by p. We are getting the result is 1 by p square. That is p is greater than 0. Okay? Sorry, one person, understand? Just once I repeat, sir. Okay?
L of minus sin 80 better.
Where, sir? Okay. That is the another problem. First problem is L of t.
L of t equal 1 by p square.
Okay, sir. First of all, we have to prove that L of t equal to 1 by p square.
Yes, sir.
Okay. What is that L of t? Given the function is t is here. What is the function? First problem is here. Okay. Just you have to see the first one.
Yes, sir.
Okay, sir. L f dash of t. That is the first derivative of the part.
Yes, sir.
Okay?
Yes, sir.
In the first problem is Laplace of f of t. F of t means t.
Yes, sir.
F dash of, according to that function, f dash of t equal to 1.
Yes, sir.
Okay. And yes, t equal to 0, f of 0 equal to 0. Okay, sir. Now yes, sir, these values substituting in first derivative.
Yes, sir. Yes, sir.
Okay, sir.
Yes, sir.
At the same time, in the right hand side is p into L of t minus 0. Okay. Now yes, L of t is also that side here. Please say that side, right side. P converting into this side. That is 1 by p into L of 1. Okay.
Yes, sir.
Now we have to find out the value is L of t is here. Okay. Now, P converting into this side, 1 by P into Laplace of 1. That is
Yes,
1
sir.
by P into Laplace of 1. Already we know that formula, 1
Yes,
by
sir.
P. So that value is 1 by P square, derived here. Okay. Now
Yes,
see
sir.
the second problem. What is the second problem? Given the function is e power at. Yes, sir?
Yes, sir.
Okay. Given the function is e power at. So that value is taken here. Here f of t equal to e power at and f dash of t equal to a into e power at.
Yes, sir.
Okay, sir. Now
Yes,
in
sir.
put t equal to 0 given that function, that value is 1.
Yes, sir.
From first equation, these values substituting in first equation. Laplace of f dash of t means a into e power at equal to p into Laplace of f of t means e power at minus 1. Okay.
Yes, sir.
These values substituting in first equation. First equation means first derivative of the Laplace transformation. Okay. Now, Laplace of e power at is also taking that side only. Okay. Minus 1 is also converting it to this side. What is that? 1 plus Laplace of e power a into e power at. So here Laplace of e power at equals to p minus a. Laplace of e power at common.
Yes,
So
sir.
p minus a of Laplace of e power at equal to 1. Finally, we are getting Laplace of e power at equal to 1 by p minus a.
Sir.
Yes, sir.
Yes,
Just here we are conclusion here. The number of formulas must be derived previously derived through the definition of Laplace transformation. Okay.
Yes, sir.
Now, same functions must be derived through the derivatives. Okay,
Yes,
sir.
Yes, sir.
First derivative or second derivative, whatever it is. The previous theorems are also explained here. And
Yes,
according to those theorems, now there are already such functions should be taken given these theorems here. Okay.
Yes, sir.
There is no confusion. Simply understand.
Yes, sir.
Okay. Next one. So Laplace of e power at equal to 1 by p minus a. Next one. Third problem is here a minus a sin at. That is the function.
Yes, sir.
So sorry for the disturbance. So let f of t equals to what is the function minus a sin at. F dash of t equal to
Yes.
just you have to say it. A equals to u sin at derivative is
Yes, sir.
a cos at. Okay. So minus a square cos at. That is the first derivative.
Yes, sir.
Again, here that derivative f double dash of t is there. Again, cos at derivative is minus a sin at. So we are getting the value is a cube into sin at. That is the second derivative. F double dash of t.
Yes, sir.
Now, here replacing of the value, put t equal to 0 in first derivative. F dash of 0 equal to minus a square, cos 0 is 1. In the f of 0 equal to, okay, sin 0 is 0.
Yes, sir.
Yes, so f of 0 equal to 0, f dash of replacing t by 0, we are getting the value is minus a square. Now from the second derivative concept, L f double dash of t equals to p square into L f of t minus t into f of 0 minus f dash of 0. Okay.
Yes, sir.
Already proved that one. Laplace of f double dash of t means a square sin at.
Yes, sir.
That is p square into Laplace of minus a sin at. Minus f of 0 is 0. Minus of f dash of 0 value is minus a square. Okay, sir. Now, those values substituting, we are getting the value of Laplace of minus a sin at equals to p square converting into this side minus a square by p square plus a square.
Yes, sir.
Okay, sir?
Yes, sir.
Simple. Here minus a is constant. Laplace of sin at expression is a by p square plus a square. Minus a into a is minus a square by p square plus a square.
Yes, sir.
Yes. At the same time, the above result is also, it follows that. What is the result? Laplace of sin at equal to a by p square plus a square. Okay, sir? That's it. And next one is the Laplace of t cos at. First of all, we must know that Laplace of cos AT is P by P square plus A square. Here P is greater than 0. Okay, sir?
Yes, sir.
And the Laplace of T into cos AT. This is the multiplication by T formula. Okay, sir? Cos AT is multiplying with T.
Yes,
we have to observe this one. Okay. Now that formula is multiplied by formula minus d by dp and minus 1 whole power n into d by dp, d power n by dp power n Laplace of cos AT. Okay. That is the multiplication by t power n. Okay.
yes,
Here
yes,
n equal to 1. So final expression is minus 1 into d power 1 by dp power 1 into Laplace of cos AT. So minus d by dp of p by p square plus a square. Okay, sir.
yes, sir.
Now that is the u by v expression.
That is okay, sir. That is okay.
Thank you. Very good. Okay, we are getting the result is the getting of the final result is p square minus a square by p square plus a square whole square. Okay.
Yes, okay,
In the
sir.
same manner, next example is also here
Yes,
the
sir.
p
Yes,
square
sir.
is there.
Yes, sir. Yes,
Sin
sir.
80 sin 80 along with t square is there. Okay.
Yes, sir.
First of all, so you have to first write as Laplace of sin 80 equal to a by p square plus a square, and therefore Laplace of t square 80. Now comparing it with the Laplace of t power n is there. Minus 1 whole square into d power n by dp power n of Laplace of the function. Here,
Yes,
minus 1 whole square is the taking the value is positive. D square by, there are two types of Laplace of sin 80 is a by p square plus a square. There are two times of derivative is there. Okay, sir?
yes, sir. Yes, sir.
Here the a is the constant is here.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Now 1 by p square plus a square. First we have to derive first derivative, and again you have to another derivative. Okay. We are getting the result is there. So see this, there are same examples. T square into e power 2t. Function is t square e power 2t.
Yes, sir. This is also released.
Okay. That is also same man. Okay, sir. Laplace of t cube cos t. Here n equal to 3 is there. 3
Yes,
times
sir.
derivative. Okay. First cos t expression. What is the cos t expression?
P
by p square plus a square. Means a means 1. So p by
Yes,
p
sir.
square plus 1 is here. Now that is multiplying with t cube. So what is the formula? That is multiplication by t power n. Minus 1 whole cube into d cube by dp cube of p by p square plus 1 is there. Okay, sir?
Okay, sir.
Next one. So that expression is 6 into p 6p power 4. There are 3 times integrate. The derivative is there.
Yes,
U
sir.
by v expression. Okay.
Yes, sir.
D cube by dp cube can also be written as d square by dp square, or Leibniz rule is also applied here. Okay. That is the simplification. A very true simplification here. D cube by dp cube of p by p square plus 1 means there are 3 times in differentiating. So we are getting the result is the same manner. Okay. That's it. Now all the formulas are in the same manner. Now 38 problem is also see here. Find the Laplace of t is also multiplying with the common function.
Oh, yes, sir.
Okay. The bracket part is the common function. First of all, 3 sin 2t Laplace value. Next 2 cos 2t of the Laplace value mentioned here. And
Yes,
at the same time, that is apply multiplying with t is there. Multiplication by t formula is minus 1 into d by dp of with respect
Yes,
to the
okay,
Laplace value.
Oh, yes, sir.
Okay.
Can do it. No problem.
Okay, sorry. Thank you. Now, these problems are also in the same manner, sir. Just you have to see here. Now,
Yes, sir.
my maximum here covered tomorrow. And one of the problem is also see this. Any critical problem, I'll also explain here. Okay.
All this matter has been sent, sir. No, sir.
Sir, same manner, sir. All these problems are depends upon the previous theorems. Okay.
All this matter you have sent it, sir. Huh?
Already sent, sir, through PDF.
Okay, sir. Thanks, sir. Thanks, sir.
Okay. Already yesterday did not see here.
Yes, sir.
Already you are in group there.
Yes, sir. I am in group, sir. Thanks,
Again,
sir.
I will send there. No problem. Okay.
No. I will see and ask you, sir.
Okay. Thank you.
Okay. Thanks, sir.
Okay. Already just before that day is also sent there. Okay.
Yes. Did you send in group or it is individually you are sending, sir?
Yes, sir. Only group is.
Okay, sir. Thanks, sir.
Okay, most welcome. Okay, sir. Now the more than problems are also just you have to reference your textbook is there. Okay.
Yes, sir. Yes, sir.
Are you have to any textbook here? University textbook is.
I have, sir.
Okay, no problem.
Every student has that book, sir.
Sure. Okay, sir. Now this is the function, sir. Prove that integral 0 to infinite. Just you have to see here.
Yes, sir.
See this one. Prove that Laplace of sin t by t. Okay. What is the just you have to share your ideas with me. What is the concept of Laplace of sin t by t? Now that is 1 by t into sin t. 1 by t expression is that is division by t. Okay.
Yes, sir.
Yes. So you have to apply the integration of Laplace transformation, where the final result is tan inverse 1 by p, that you have to prove here. Okay. What is the value of Laplace of sin t by t? And hence deduce that find the value of Laplace of sin at by t is there. Here the f of t equals to sin t and limit t tends to 0 f of t by t. First of all, so you have to find out this value. Limit t tends to 0 sin theta by theta equals to 1 is there. Okay, sir? And according to that, here, Laplace of sin t equal to 1 by p square plus 1. Say that value is f of p here. Laplace of sin t by t equals to integration by integrated the result on Laplace transformation, integral p to infinity to f of x dx. Okay. Integral p to infinity to f of x means dx by x square plus 1. Okay, sir?
Yes, sir.
Here the f of p equal to 1 by p square plus 1, f of x equal to 1 by x square plus 1. Okay?
Yes, sir.
Of dx. So what is the formula of integral 1 by 1 plus x square dx? 1 by a square plus x square equal to 1 by a into tan inverse x by a. So here a square equal to 1. So you are easily to understand here tan inverse x. The formula is tan inverse x. That values also varies from p to infinite. Substituting the result, tan inverse infinity is pi by 2 minus tan inverse p. Okay, sir?
Yes, sir.
So here the pi by 2 minus tan inverse p can also be written as cot inverse p.
Yes, sir. Yes, sir.
Okay, cot inverse p can also be written as tan inverse 1 by p. Okay, yes, sir? Here because cot theta equals to 1 by tan theta. That expression. Okay. Now that is also same. Laplace of sin at by t equals to a into Laplace of sin at by at. A is also multiplying with. Okay. Simple expression, sir. A into Laplace of sin at. This is the second version. A into Laplace of sin at by at. A is also multiplying with given the function. A into Laplace of sin at by at means 1 by a into tan inverse of 1 by pa. That is the deduction part. The problem is also combined with deduce that Laplace of sin at by t is there. So a is multiplying with given this expression a into 1 by a into tan inverse of 1 by p minus a. A cancelled. Final expression is tan inverse a by p. Okay, sir? In the same manner, Laplace of cos at equal to p by p square plus a square. Say that value is f of p. Now that is also multiplying with 1 by t is there. Okay. So what about the final expression? Integral x dx, x by x square plus a square of dx equal to integral x by x square plus a square dx equal to, that is 1 by 2 log of x square plus a square from the formulas, integration, related integrated formulas. Okay, sir? That is where the values are substituting here, upper limit and lower limit. We are getting the value is simple value. 1 by 2 limit extends to infinity to log of x square plus a square minus 1 by 2 log of p square plus a square. But here, first expression does not exist. That is the infinite part. Okay. So cos at by t, is it exist?
Does not exist. Yes, sir.
Yes. Okay, sir. That is also this easily problems, easily to solve. Okay. Yes, this type of problems are also must be easily solved. Okay, sir.
Yes, sir.
From the cos at by t. Now, is it exists or not? The Laplace of cos at by t. So that does not exist.
Yes, sir.
Okay. So you have to see this one, enter all these problems. That is the simple expression. Okay, sir. Tomorrow, we will explain the another concept here. This is also evaluation of integrals. Okay, sir. Laplace of f of t equals to f of p. Laplace of 0 to infinity e power minus pt into f of t dt equals to f of p. Okay, sir. That expression integration and transformation, integral transformation equals to f of 0 is there. According to that, you have to easily to solve it from the Euler concept. That is integral 0 to infinity e power minus cat of minus e power minus pt by t dt. Okay, sir?
Yes, sir.
Easily understood. Now, this problem is also very important from the above problem. Put a equal to 3 and b equal to 6. We are getting the result is log 2 of the problem is integral 0 to infinity e power minus 3t and minus e power minus 6t by t dt. Okay. Now, yes, these are all so many problems are also solved here. Okay.
Yes, sir.
Thank you very much. Again,
thank you, sir.
Tomorrow we'll meet again. Laplace inverse transformation and we have the convolution theorem and according to their problems are also see there. Okay. Thank you. Thank you, one another.
Thank you, sir.